Welcome back. Let's do our review of axis of symmetry, vertex, and then maximum or minimum. Easiest one is determining vertex. It's our turning point, so where it starts going down and coming back up, or vice versa if it is flipped. So our vertex for this first example would be the coordinate point -1, 0, where for this example over here would be +1, -4. Now, if we look at the vertex, is it a maximum or a minimum? Well, you'll notice that in each of these, it's at the bottom. Remember that if it went this way, this is when the vertex would be a maximum. Axis of symmetry is just the line that makes the parabola symmetrical, and the vertical line we know is always x equals. And so we look at where does it go through? Well, it goes through the x-axis at -1, and if we repeat that on the other graph, it goes through the x-axis at +1. Another thing for review that's really important, if the coefficient for the x squared term is positive, it will open upward, okay, so remember that, and negative means it will open downward. Okay, so these have opposite effects, which is why they're in the same color. Now when we go to the next set, we have whole number. Remember that makes it narrower. So where we're used to seeing maybe something like this over here, it would instead shrink a little and become something very narrow, like this. So you may want to draw this picture next to the whole number description. Now with the fraction, when the fraction is smaller than 1, this will make the graph, the parabola, wider. So again, if you would like, you should draw out this picture that it will make the graph wider when it's a fraction. Okay, and the reason these are in the same color is because these are opposites of one another. Easy, right? Of course. Now remember that the standard form for all quadratics is ax squared plus bx plus c. A, b, and c are all just coefficients. Alright, so if we look at some examples down here, a is the coefficient in front of our x squared term. Well, you'll notice that there isn't one written, which means it is just the number 1, because we do have x squared here. B is our coefficient in front of the x, so that's -2, and c is our term with no variable at all, so that's 4. Moving to our next example, a, again, in front of our x squared term, so that's -1 this time. And b is our term, remember b is with our x, and you'll notice that we don't have a term that has just an x, so it's not there, which means it's 0. And c would be our -5. Don't forget that this negative goes with the 5. Okay, so those are grouped together. And then in our final example, we have 4x squared plus 2x. Our a is 4, it's with the x squared term. B is 2 because it's with our x term, and then c, we do not have one, so it's 0. See, this is easy. You totally got this. When we were graphing these today, remember that we take our x values and plug them in. So this is just a brief example. Remember that when you are using these values, put them in parentheses and then follow the order of operations. Square first and then multiply, which would end up giving you the coordinate point -1, 2. So we put that on the graph, -1, 2. When we put in 0, we end up with 2 times 0, which is 0, so the coordinate point 0, 0, or the origin. And then, of course, 2 times +1. +1 squared is also +1, so we get 2, which is the coordinate point 1, 2. And then we connect it, remember to make it a U shape, and there we go. So the 0, 0, remember that this right here, would be our vertex. Alright, and then this would be a minimum. And our axis of symmetry would be x equals 0. So why is the standard form important? Well, first thing is because you can find the y-intercept. The y-intercept is always, 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 always the term without a variable. All right, so with this, if it's not written there at all, then it's 0, and if it is written there, it's whatever number. So if we come back to these previous examples, right here, our y-intercept would be the point 0, 4. Pretty easy, right? Now with this one, we didn't have a c value, so that meant that our y-intercept was the point 0, 0. See, you've totally got this. Finding the axis of symmetry, now we can do it without having the graph. We can calculate it on our own, which is kind of nice when we get to graphing them because we don't have to kind of guess and check and plug numbers in. So we take negative b over 2a. So we take our b term here and divide it by 2 times our a term, and then it's negative, so it's always the opposite of what we have. Now this part looks confusing. This is just your axis of symmetry, okay? And then what you do is you plug that into the function. So then plug axis of symmetry into the equation, okay? So it seems confusing, but it's not, and I will do some with you. So, acting like a kangaroo, hop into the problem. We start with something simple and easy. A here is 1, B is a negative 6, and C is a positive 4. So remember the 1 comes from in front of the x squared term. Now, axis of symmetry, x equals negative b divided by 2a. So we take x equals negative. Now we put b, remember every time you plug in a number, put it in parentheses, over 2 times a, which is 1. So we end up with a negative times a negative. Remember that that's positive, so we have 6 divided by 2. So our axis of symmetry is the line x equals 3. All right, so what that means now is our vertex 3 is our x-coordinate, and I got this from our axis of symmetry. To get the y-coordinate, it's just plugging in that value to our original equation. So we take 3, square it, subtract 6 times 3, and then add 4. Order of operations, 9 minus 18 plus 4. 9 minus 18 is negative 9 plus 4. Negative 9 plus 4 is a negative 5. So our y-coordinate of our vertex is negative 5. So our whole vertex is 3, negative 5. So there's your answer. Ready for another? So as we move into this one, listing out A, B, and C. This time A is negative 4. B, what do you notice? Well, remember that it's ax squared plus bx plus c. There is no bx term. So that means b is 0 and c is a positive 11. So when we go to find our axis of symmetry, we have negative, and we're plugging in 0 for b, and then 2 divided by negative 4. One important thing to remember, anytime the numerator, so anytime the numerator equals 0, the whole fraction is 0. So then that means our axis of symmetry is x equals 0. So there's your answer. Remember to take that. It becomes the x value for your vertex, so 0, comma. Now we take this number 0, plug it into our original equation. So negative 4 times 0 squared plus 11. So 0 squared is 0, so negative 4 times 0 plus 11 So really, you have 0 plus 11, which is just 11. So there is your vertex. See, you guys have totally got this, right? Okay, well, I'm stepping it up. Are you even ready for this? I know you want a tough one, so here you go. Now, this time, A is a fraction. Oh my gosh, what? B, -2, and C is a -1. All right, axis of symmetry. A equals -B. B is -2. Divided by 2 times A. Remember when you are multiplying fractions to change the 2 to be 2 over 1 times 1 over 4. Multiply straight across so you get 2 over 4 and then simplify so you get 1/2. Negative times a negative is positive, so we have a positive 2 on top over 1/2. Well, now you're thinking, oh my gosh, how in the world do I do this? What do I do? I have to divide by a fraction. That was you having a panic attack, by the way. So, well, think about this. What does dividing really mean? Well, it means to multiply by the reciprocal. So for that example, we had 2 divided by 1/2, right? Well, what does that really mean? To take 2 and multiply by the reciprocal, which would be flipping this fraction upside down, 2 over 1. Well, that's just the same as 2 times 2, right? Which is 4. Oh my goodness gracious, you have got this. Are you impressed with yourself or what? Because I am pretty impressed with you. I am. All right, so here was our, our information from our previous. This was the same problem. Okay, and we had our axis of symmetry given as a, oh no, you can't see that yet. No, you can't see that yet. I'm not gonna get rid of the stuff. Okay, so we had here, this was our A, this was our B, and this was our C, okay? Now, we multiplied this out already and got x equals 4 as our axis of symmetry. And then to find our vertex, we take our x value, remember that this is where this 4 comes from, and then plug 4 in. I don't know where this 1/4 came from, ignore that. I have no idea where that came from, sorry. So we take 1/4 times 4 squared minus 2, no, minus 2 times 4 minus 1. Order of operations, 1/4 times 16 minus 8 minus 1. 16 times 1/4. 16 times 1 is 16, divided by 4 is 4. So now we have 4 minus 8, which is -4. -4 minus 1 is -5. So 4, -5 is our vertex. All right, well guess what? You did it! Yay! Where'd it go? See, now I want it to work. Oh no! Let's see if I can get there. Yay! We did it! That's what Dora says. So, guess what? It is officially time to rock. Good job, and see you very soon.